Good afternoon. This is Eric Howard at Second Nature. Welcome to today's Second Nature webinar on approaches to distributed energy as a factor for your overall sustainability strategy. Most of the people listening today are based on campuses that have made leadership commitments with respect to carbon, climate, or resistance. A core component of carbon and climate commitments is achieving campus carbon neutrality, but achieving this needs to be done in a very cost-efficient way. There are many technologies to choose from, and the process of taking new ideas from concept to construction can be unclear, hence today's webinar. Distributed energy systems are an ideal component of an institution's plan for sustainability and carbon reduction. For today's program, Second Nature, Siemens Building Technologies, and Arizona State University have come together to discuss an applied methodology on how to transform campus energy management through on-site generation, thus meeting sustainability goals while also controlling energy use and cost. DES, Distributed Energy Systems, falls within a framework of renewable energy procurement options that also include PPAs and renewable energy credits. We're pleased to present this webinar as a case or an example of effective methods for implementing DES at a large university. The three speakers will also address how to customize and tailor DES for smaller institutions. And they'll address some of the applicable technologies, be it solar or battery, combined heat and power, wind, or microgrid solutions. So today's speakers are myself. My name's Eric Howard. I'm the moderator, and I'm Director of Strategic Partnerships at Second Nature. We also have Nate Johnson at Arizona State, and two experts from Siemens, Todd Thurlow and Clark Wieditz. The agenda for today is that first Todd will give an overview. After that, Clark will talk about microgrids. And finally, we'll hear from Nate at Arizona State about their recent experiences. We've also reserved time at the end for questions, and of course, you can follow up with any of the speakers at your convenience. At any time during the webinar, you can submit questions through the chat box on your screen. This webinar is being recorded, and the recording will be sent to the registrants, and it'll also be posted on our website for others to see. Before I hand over the microphone, I'd like to give a quick thank you to the corporate partners that Second Nature works with, including today's sponsor, Siemens Building Technologies, and also Customer First Renewables, McKinstry, Metris Energy, Greener U, and Open Road Renewables. A full list of sponsors and partners is on our website, secondnature.org/partners. And now on to the program.
Great, thank you, Eric. So as Eric mentioned, a growing number of higher ed institutions are committing to carbon neutrality. As the slide shows, 372 signatories have committed to reaching carbon neutrality by 2050. 4 have already become carbon neutral. The use of renewable energy is an essential component of a strategy to achieve carbon neutrality. And approximately 44% or so of those 372 signatories are already consuming some portion of renewable energy. And implementing on-site distributed energy renewable projects are a great way to increase that renewable energy consumption in the supply, as well as provide additional benefits to campuses that we will discuss. Eric, if you can go to the next. So I wanted to talk about different options for procuring renewable energy as part of a supply portfolio and illustrate some comparisons. So there are 4 options that a campus could undertake to increase renewable energy in their supply portfolio. The first being purchasing renewable energy credits, or RECs. It's the pros of this: it's a simple transaction. There's minimal risk. associated with it, but it does nothing for the energy side because you're just purchasing the green certificate. So it doesn't impact your energy supply portfolio at all. It doesn't provide any cost benefits or any risk mitigation to market prices. But again, simple transaction. Another option is what's listed as the off-site power purchase agreement, otherwise known as a virtual PPA or a synthetic PPA. This is where energy is purchased directly with a generator off-site, a wind farm or a renewable generator off-site. This provides benefits in terms of oftentimes these PPA, these contracts are at a fixed price, which provides some cost certainty going forward. So that's a plus, as well as the reputational and brand benefits. Some challenges associated with this approach is it's a more complicated transaction, and there's risk inherent in how it's purchased. The point of purchase may be a hub within the market that's subject to some transmission fluctuation, and so there may be some congestion pricing that's built in there. So it becomes a more complicated contract structure in terms of the location or basis risk. And there's also a risk of variability of the production relative to the consumption profile. So there's volume risk and there's price risk that can be built into that. A third opportunity is the retail electricity agreement in deregulated markets that can be available, where a short-term contract is purchased from a third-party supplier. In some regulated markets, utilities are offering green tariffs, and those are available as well. So that is, again, it doesn't have the contract length that the PPA has, and it's offered at a grid competitive price, but there's a restriction to where those opportunities are available in deregulated markets for retail agreements and in only very specific utility markets for the green tariffs. So now let's talk about a distributed energy renewable project, a solar PV or a solar plus storage or other technology that's built on site. That opportunity provides it provides the same benefits of cost savings. There's abilities to mitigate the risk of market pricing fluctuations. So there's some added certainty or physical hedge there. It also provides additional resiliency with having generation on site. If there's interruptions in the grid, the campus can be less impacted by those. And finally, it provides opportunities for learning programs, living labs, and other educational opportunities that can be incorporated into those projects to benefit the educational mission of the institution. But there are some physical requirements associated with those. There must be area or real estate available for them, and they do represent a longer-term commitment. So if we can go to the next slide. So when evaluating, identifying and evaluating a distributed energy project or a microgrid project for a campus, we follow a very structured process that's laid out here. And we do that to be efficient with time, to quickly evaluate the potential benefits, both from an economic perspective, a sustainability perspective, and a resiliency perspective. And we have multiple steps shown here. The first step, the preliminary analysis, is where the primary element of that is developing a baseline. What's the baseline of consumption? What's the baseline of cost? Once we have that, then we can create some conceptual designs of different distributed energy projects and see how they compare. Do they provide cost savings? Do they provide improved resiliency? And do they, what is the impact on the renewable energy objectives? And that tends to be done at no cost. And then if that shows itself to provide an attractive project, we move into a more detailed analysis where firm costs are developed, engineering is provided, firm engineering is provided, and an implementation approach is developed in conjunction with the institution. And then from there, if the project passes the sort of capital hurdles and the business case is robust and attractive, then we move into, delivery and installation, and then finally, ongoing operation measurement verification. So there's a very structured process to develop, evaluate, and implement distributed energy projects. Next. And a key component of that process, especially the first phase of that process where we're evaluating the opportunity, is a key component of that is we use a proprietary tool set to quickly and efficiently screen options and optimize the design around technical, operational, and economic parameters. And it allows us to, again, rapidly look at different design options, compare those, and move on to more of an optimization stage. And what this graphic shows is where we start in the top left is having that interval data around the load profile. Critically important that we start there. That's our baseline. And then from there, we also simulate in this this modeling platform, we simulate the existing generation and the existing equipment and how that's laid out and interconnected. Again, developing the baseline. And from there, within the simulation engine, we develop equipment configurations that include solar, photovoltaic, they can include batteries, they can include combined heat and power options. And we look at those configurations, and then we dispatch those on a time step, be a 1 hour or a 15-minute time step, and we create dispatch profiles for a year, a base year. And from that, we get all the economic data coming out of that. What is the capital cost? What is the operating cost, et cetera? And how does that compare to the baseline? So at the end of this, it allows us to look at options A, B, C, D, E, and determine if any of those meet the objectives of the institution in terms of economics, sustainability, and resiliency. And if so, we kind of narrow in our focus on one or a select of those, and then go into more of an optimization phase where we tweak the design to meet the specific requirements of the site. So that's a little bit on our process, and now I'm going to turn it over to Clark.
Hey, thanks, Todd. Before I get started, I just want to remind everybody in the audience that in order to ask questions, there's a questions bar on your panel. So as you go through and you hear things that we're discussing, please go ahead and scribble out your questions, and then we'll address those after the final speaker has completed. So as Todd pointed out, this tool, it allows you to evaluate various scenarios for a potential microgrid project. It can have a diverse set of assets and loads, like you see in the diagram in front of you. Assets such as generators, renewables, storage, EV car chargers, and you can even have a building automation system wrapped up underneath your microgrid controller. We've also found a diverse set of drivers. Now, being an engineering company and an equipment company, it's natural for us to always focus on the technical solution and the technical drivers such as reliability and resiliency. And depending upon factors such as market segment or geographical location, these could actually be the #1 motivation for a microgrid project. However, it's still difficult for any of us to calculate the value of resiliency. I'll say unless, of course, you have a lab or you have a data center on campus that can't have any type of power interruption, then it's easy to calculate those numbers. That being said, and depending upon the current distributed generation assets that you have on campus, I'll also add any assets you may be planning for in the future. Our customers are actually finding economic benefits by adding either additional distributed generation, battery storage, and advanced controls in order to have a microgrid. Thirdly, reduction of greenhouse gases and reduction of your carbon footprint. They're also KPIs for many institutions nowadays. It is expected by the generation of students that you have, and therefore it's a driver for their choice of your institution versus another one. All of these drivers should lead you to at least investigate whether a microgrid potentially makes sense for your campus. Go ahead to the next slide. Once an attractive project is identified, higher ed institutions have a wide variety of implementation options. This is dependent upon their strategy and access to resources, of course. More and more institutions are taking advantage of partnerships in order to preserve capital or even avoid capital expenditures. They can shed operational responsibility and risk, and they can also maximize the value of these existing generation assets. There are wide ranges of partnership options that allocate operational risk between the campus and what we'll call a third-party partner. Thus, having this third party assume more operational risk as the options move to the right on the chart that you see in front of you. Now, these strategic or third-party partners that we talk about, they can provide more than just financial or operational support. They can also provide help with educational and research programs as well. This additional dynamic could be the driver or the additional impetus that's needed in order to have distributed generation or a microgrid on your campus. Go ahead to the next slide. So within the last year, Siemens is working with colleges and universities on their microgrid training program in order to help drive research, student education of microgrids specifically, utilizing advanced control systems. By installing advanced software controls that oversee, I'll say, kilowatt size assets, it allows the students to model, to run simulations, and to realize capabilities and functionalities that are actually part of a regular or a large size microgrid that you would see on a campus, a university, or even a utility. Capabilities such as islanding, load shedding, load shifting, and voltage synchronization from black start mode are just some examples of capabilities that I'm talking about here that you can model using your kilowatt size microgrid. These things are actually called nanogrids. It's a term that's out there that describes, I'll say, this size of a microgrid, and allows simulation for what's being done on campuses or federal bases, healthcare sites, and also large utility companies. It's all about workforce development. There's a shortage of students with knowledge of advanced control systems. So these programs can give them an advantage when they're finished with their education, and when they go out into the work world, they can work for companies like Siemens. They can work for utility companies, the federal government, or even right there on your campus. So this is what we're trying to drive for, a combination of education and research that blend in with advantages for your campus in order to have a win-win situation as a programmatic approach for your institution. With that, I'd like to introduce you to our next speaker, Dr. Nathan Johnson of Arizona State, and he'll elaborate more on the reduction of carbon, as well as the part of the microgrid, and most importantly, workforce development. Nate? You might be
Great
muted.
to be on the call today. Thanks, Clark. To be invited in to speak to the group along with Siemens about distributed energy, carbon reduction strategies, and then also campus scale innovations, which involve facilities, research, private sector developers, and utilities to come together to create solutions that not only drive a low carbon economy, but provide the opportunities for the next generation of engineers, scientists, regulators to instantiate that change in the rest of the world. And so that's part of the intent and work to speak with you today. A bit about Arizona State and how it's kind of contextualized our approach to this is we've been pushing the philosophy of being a new American university, which drives itself by doing use-inspired research. And so while Performing publications as typical researchers and scientists, we realize that we need to follow what we classify as the science plus model, which is to do science and something else. And so that's educating the workforce, not just in the classroom, but working professionals out there today. It's creating rapid prototype technologies that we can go from basic science to a turnkey prototype in the matter of months instead of years, that then get translated to the commercial sector with our private sector partners. It also includes working with regulators and advising and working with utilities, while also obviously seeking advice, because in a fast-moving environment, to assume everything would obviously be the incorrect strategy. And so I'm happy to say that we learn as much as we share. I would say possibly even learn more in certain circumstances. And while we look at our university that's been growing, we're now the largest university in the United States at 111,000 students. And so we have to ask ourselves, as we grow, as we look to educate more people for the changing world, we realize that goal also comes with certain energy, water, and waste consequences. And we've been making great strides in the last 15 years to reduce that. Principally for carbon neutrality, we've set that for buildings by 2025 and 2035. And achieving that takes procedural organization and strategic insight. But then from an operational level, how do you instantiate the concept of innovation that permeates your organizational processes, but then also your research and education? And as a result of not only doing the research education, but then reforming ourselves and remaking ourselves, we're been happy to receive U.S. News and World Report as the #1 university innovation for the past 4 years. To be a bit more specific on that energy side, we have in excess of 50 megawatts of solar PV on-site or off-site. And then there's a couple different units. We have a 9 megawatt and planning to double down on that for phase 2 for combined heat and power. And that microgrid provides power to our research facilities, and then in the winter it provides steam for heating purposes. Whereas in the summer, with our series of new chillers that have been installed, provides a significant cooling capacity, noting that we're in Arizona and you sometimes have days where you're in excess of 115 degrees heat for about 3 to 5 days. And there's 6 million gallons of thermal energy storage chilled water to ride through those high energy or high peak times. Next slide, please. So as a researcher and looking at how I work with facilities, developers, utilities, regulators, the defense industry, and other groups, I ask a couple different types of questions. And I usually say I have to put on 2 hats, noting that I had a longer time in the private sector than in academia. The first hat is putting on that academic hat. So where can I provide the publishable nugget of basic science and applied research which advances our thinking on a particular subject? The other hat I put on is how do I translate that into consumers' hands? And so that's the private sector hat I put on. How do I translate that science into that plus model where it then has an additional measurable impact on humanity, whether it be increased safety, improved reliability, improved resiliency, decreased energy cost, or increased renewables? So as Clark and Todd were telling you about that early stage of the process of doing your microgrids and analysis, it's really important to be able to rapidly move from initial ideas to a preliminary concept. So one of the partnerships that we've developed with some support from the Office of Naval Research was a group called Zindi out of San Diego. And some of their back-end software computation is also from OpenDSS and then DIRCM for the folks in the room that know those 2 simulation packages. And so what they've done is been able to pull together those federally funded or private sector funded for OpenDSS open source packages and resource tools into an intuitive user interface that you can log online and analyze a lot of the systems for yourself. One of the things that in our partnership in the last 2 years, and we've been very happy to work with them on this and use them extensively in our work, is it gets classified into 3 forms of rapid reporting. First is a high-level pitch deck they would use for your C-suite or manager-level decisions. Second is a detailed technical analysis and reporting, so single-line, 3-line diagrams, power flow analysis, bill of materials, financial cash flow, arc flash, motor starting, and those types of issues. And then also thirdly is the financial, the cash flow, so you can make sure that the investments you're doing are going to make sense from the bottom line as well. And what we found valuable and where we've partnered up is actually providing a significant amount of training using these programs and then applied on our projects with developers is that we want to move that earlier stage of the conversation from weeks into days or potentially even hours, depending on the complexity of the models that need to be run. And so whether working on a GIS layout, so you can drag and drop the different locations of your buildings and it automatically draws your distribution network, identifies the appropriate assets, locates those assets, and then sets up the protection equipment so then everything else is satisfactory, to then going to time series analysis, and then as I indicated, the power flow, but then also implementing a project management framework, because the intent is to bring that preliminary design, detailed design, financial reporting, but then also the development process into one tool so that everyone gets the same experience from soup to nuts, you might say, or end to end. In that case, there's been a few dozen projects, some more recently by the Federal Aviation Administration, other groups, to put their projects into this program to be able to monitor and track. So if you have 10, 15, 20 microgrid projects, you're at a little bit higher level, but you can drag into the level of details and power flow and one lines if you'd like. And then my group is providing the training services, and I'll get to training a little bit later. As a side note, thinking as a researcher, we provide some of the algorithms that would then go into Xindi. We provide the training, that's part of our role. The third role is that we are what one might classify as a super user. So we get alpha, beta versions to help provide feedback, but then also we apply in our projects. And what's great about this is, much like Siemens, Xindi is a group that is comfortable and interested to work with academia and research partners to say, how can we have public-private partnerships where there's research and the commercial aspects going on at once? And so that's where the support came in from the DoD entity ESTCP for Southern Research, myself at Arizona State and Xindi, to do microgrid design and evaluations for 5 military bases. And so those are storage-based microgrids, somewhere between a few hundred kilowatts and a few megawatts, to assess the technical and financial efficacy. But then for my team doing research in controls, forecasting, and resiliency algorithms, we will then program those, and then leading into phase 2, we'll then test those in my test bed here before we go to full-scale implementation on base. Next slide, please. So after that design process and that importance of shortening that and getting that faster to reduce the soft cost of engineering design, we realize that when it comes to integration, nothing is really ever as plug and play as a USB key. So how do we get to that level of consumer or customer experience where things are easier to put together, or from the integrator, easier to put together so there's less troubleshooting in the field? And so again, with some funding from the Defense Department, another private developer in Colorado, Agito, a utility, SRP, and then Verizon for telecommunications, we put together a partnership as well as a series of commercial grade software, some research utilities into my test bed to develop the next generation, as we're saying, of plug and play assets that are intended to be vendor agnostic, as we try to create microgrids that are more commoditized, and so they take less time and less design to put together. And so that's the intent. And part of that's driven not only by that interest in the interoperability, but also for on-grid and off-grid applications. In off-grid, you might have what we classify as a dynamic topology. So you have a distribution network in a building or a campus that's kind of static. Nothing's changing that much in terms of the wires and the buildings and where they're located. But if you're in a disaster response scenario or forward operating base, or potentially in an island location, you might be adding, removing, or moving around assets as you move from, as the military would say, contingency to enduring operations because your mission objectives change. Given that my group has some experience in disaster response, and that's how we got started in off-grid development, that same scenario is not uncommon as we try to provide power to 1 billion people that don't have it. So then how do you develop the control techniques that are distributed and don't require a centralized brain, so that every time you add something, remove it, or move it, you don't need to encode or recode that central brain or hierarchy? And so that's what you see, the linking microgrids to maximize solar utilization. We borrow some principles from how ants and bees behave in swarms, and that's how we program the individual microgrid asset level intelligence, so that they are individually intelligent, but then as a group, they have behaviors that make sure we're stabilizing voltage, have a common frequency, but then also turning assets on and off with forecasting, scheduling, so we can reduce cost and then also reduce fuel use. Next slide, please. So we've talked about on-grid applications, and that's the focus of the webinar, but it would be good for me to also describe to you and indicate that how the research and how the work you're doing in other universities can benefit other folks around the globe. So I talked about some of the private sector and defense applications, which are generally classified as dual use technologies. On the outside of that as well is a question of how do you understand that basic fundamental behavior of the electron, or cash flow mechanisms and warranty standards and technical standards, and create products and services that then help people around the world. And so there's 3 projects in front of you, originally beginning with a private sector partner, and you're finding that as a theme. We do a good amount of federally funded work, but then also private sector involvement from NRG and then a spinoff, FastGrid, to do containerized microgrids. And this is something that obviously isn't new. You know, Connex boxes being used as early as the Korean War. People have been putting power in them for decades. But then getting back to that last slide I was indicating is how do you design those so that you can easily and seamlessly add these together in a row, connect them together, and there's no issues with power electronics scheduling and maintenance. Additionally, there's some work in the middle. So again, understanding what can we do from the work we're doing in energy management systems and buildings and homes here at Arizona State and in the Phoenix Metro, to extend that and say, how do we work and design power electronics and scheduling assets in areas with weak grids? And so this is specifically Lebanon and Jordan, where we've designed some custom power electronics and controls, borrowing a lot of what we are funded and financed to do for the American grid, but then translate that obviously for different voltage and frequency settings for Lebanon and Jordan. And then some of that work for us is providing the power that then goes to provide to the water, noting that you can't get high quality and reliable water without high quality and reliable power. So my group provides the power, we expand that relationship with water, and then that water is currently provided to 181,000 refugees and local citizens in Lebanon and Jordan. Lastly is another interesting thing. So, you know, with the university partners in the audience and researchers and facilities folks, is additional expansion of architectures, but not just power and water, but other services some might need. For the researchers in the room, you've heard of the food, energy, water nexus. And while we're not doing food, there's also a definite need for clinics or healthcare when you're speaking about, you know, refugees. So you see a couple of renderings that I just signed off on last week, and that's a 40-foot container that will provide primary health care for a community of 12,000 people in northern Uganda. And then with our power system and then our water system as well included in that, it'll provide power and water for that community as well. And so with 2.1 million refugees just in Uganda from South Sudan and then also the DRC, the Democratic Republic of Congo, there is an increasing need for a variety of different types of services. And so this is something that I would encourage just from a structural approach for the facilities folks in the room, for the university admin in the room, and for the university researchers and students to think about creative ways that you can share information to unlock these types of opportunities. Because not only are they very, very fun to do and very fulfilling, but they're also additional ways that you can differentiate your university and gain additional funding and revenue to do other types of projects. And as what I was saying is that Science Plus model. Next slide, please. The last thing that I want to mention to you is training. And so I'm really happy that Clark brought that up, and I'm really happy to speak with you today. Often when you think of higher education and the purpose of how academics or academia started in the first place, it was for 2 reasons: knowledge generation and knowledge dissemination. When we think about disseminating knowledge in a university setting, that's often construed as in class or in publications or a conference proceeding. It's important to realize that the majority of the world's population won't be able to sit in your class and may not read your publications. So the existing workforce out there, how do you learn from the private sector? And then how, by the skill sets and knowledge that you've developed that is unique, then provide back to inform them on rapidly changing technologies, finances, and regulation. So my team's developed 7 training programs, a couple in association with our private sector partners. And these were started with a focus on military veterans. And so that's a Microgrid boot camp, which was a 5-day in-person experience. And you see on the lower left, designing microgrids. Then in the middle, going over integration, the gentleman there wearing the arc flash suit, touring power plants. And then on the right, that's operations. That's actually Marine Corps Station Miramar, and a system that should be turnkey in January 2019 for their system. So we have design experiences here. You do the simulations about what assets do you use, how do you integrate them in a microgrid, and then you go do that hands-on. So that's another 2 days. You do hands-on integration. And then one of the things that I really like about our 1 acre microgrid test bed and the 20 to 30 assets we have out there is we set up experiences that not only do you integrate and then obviously you operate, but we will trigger different types of fault conditions or different types of error scenarios so that you are forced to troubleshoot in real time, because nothing goes together exactly as you might expect it would in an integration. And there could also be an operational issue. So giving people that safe environment and then also very immersive environment to work through troubleshooting practices is something that we found very unique and has had a significant contributor to folks, not only veteran students, but folks that have transitioned and often work for utilities now come in to take the courses, regulators, technology vendors, and others, and also developers. So extending that forward, we started off with 50 people the first year. The second year, we were training 200 people. And then with some recent interest from private sector and federal agencies that you see there on the right, we're expanding that this next year to 600 people. And so that's going to be a great effort for us. We're very pleased and excited to do that. Doing microgrid master classes, 2 to 3 days. We've done that for World Bank, USAID, other universities, electric utilities on specific specialities, usually separated by managers, regulators, designers, technicians, and installers, because those are slightly different skill sets. And then as you see there on the lower right, part of what we'll be doing this next year with Marine Corps Station Miramar is actually providing customized training on their microgrid. So it's a $20 million microgrid, and that's our operating control room, which you see, which is obviously currently in construction. But we'll provide the customized training for operators to go through and understand what to do and what not to do. And that'll be developed hand in hand with the installation energy manager there you see in the middle, Mick Wasco, and that'll be implemented starting in summer of 2019. Some other programs we have is grid security, and so those is developed with the company Inksys or Incremental Systems out of Seattle. And again, much like we have with a partnership with Zindi, we utilize their software, we train people with their software, but then also we develop that, that research or that added value that then gets encoded into their own algorithms that then they provide to the public sector for commercial benefit. So with that work, you set up in kind of a wargaming experience where there's a red team and a blue team, and 4 people are, in an attack scenario, a cyber attack scenario, and they have the ability to turn off gen sets, open and close different breakers, mess around with your low tap changers. And then on the defense scenario, you're trying to basically keep the lights on. And we do that for a synthetic grid up in the Pacific Northwest, which is a very entertaining and enjoyable experience. And then there's some online programs which we have partial online already, but then in Q1 this next year, those will be fully pushed online. I'll be happy to share more information on that for anyone that has interest. Lastly, I just wanted to say, again, these programs also come with a significant amount of advisors, even outside of the direct partners who are funded with us. And Siemens is one of the most influential partners in there, as well as another 4 utilities that provide us direct context advice on how it connects in with their projects and opportunities. And so for the folks in the audience, whether you're, again, facilities, researchers, or admin, identifying those conversations and broaching those topics and learning what their markets are and then trying to find out the connections has been valuable for our team. And I hope the examples that I've shared here have been influential. And after this, I'll close on my section and hand it back over to Eric.
Okay, thank you so much for the presentations. We're exactly on time. We've got about 20 minutes remaining for questions and answers. As was mentioned earlier, you can type in some questions and I will receive them and I'll read them out. We already have a couple. One of the questions, it relates to funding of DES projects and the opportunities for government incentives for DES projects, probably at the federal level, just because at the state level, it would be very variable based on the state. But can you talk a little bit about what's happening at the federal level?
Well, this is Todd. Yeah, let me, the obvious and the most prevalent and widely implemented would be, the investment. There's a 30% investment tax credit available for a solar PV on site. There's also, that project would also be subject to accelerated depreciation, 100% bonus depreciation over essentially the first year. So that's pretty attractive. And together, the bonus depreciation and the 30% investment tax credit, represent a significant portion of the cash cost of the project. Additionally, a combined heat and power project or CHP project is subject to a 10% investment tax credit. So those are a couple of the primary federal incentives that are used.
Are there any states that are doing something particularly innovative that other states should be modeling?
Sure, I'll jump. Todd, you
ahead.
want me to jump in on that one? Yeah. So,
Sure.
For example, for microgrids specifically, you've got a couple of states. California Energy Commission is probably the biggest one from a funding perspective. They, for the last 5 years, have twice put money out there for microgrid projects that teams, and I will call it teams, have put together. Teams being universities, design engineering companies, the private sector, and then I'll say an end user or even possibly a developer. But those teams are put together, they submit their project to the CEC, and then the CEC has granted them anywhere from, I'll say, hundreds of thousands to up to 7 million, actually, I think was the highest number on the last one. So state of California is trying to drive microgrid projects that are ready to go into final design and implementation phase. Same thing in New York with NY Prize, which is something you guys can Google if you haven't heard of that before, but similar, structured a little differently, and the dollars are allocated a little differently, but the driver is the same. They are putting money out there, and they want teams that have microgrid projects that are ready to go into the design phase and that are, I'll say, can be constructed, makes sense from a feasibility standpoint.
Yeah, and California also has the what they call the SGIP, self-generation incentive program, which they apply to combined heat and power. It also applies to battery storage at a pretty attractive rate. I think it's around 39 cents a watt or something like that. So there's a pretty lucrative state incentive in that SGIP for battery storage as well as CHP.
Yeah. Are there some other types of partnerships that universities and colleges might consider?
Nate, maybe you should talk a little bit about some of the grant programs that you guys are, where you're teaming with other universities and private sector. I think the audience would like to hear that.
Happy to. So when I think about microgrids at universities, since a university is driven by education and research, you would want to classify those into maybe a testing microgrid and an operational microgrid. And so Clark and Todd were giving good examples of financing and vectors for operational microgrids, even though a couple of those entities could, like California Energy Commission, be happy to provide money for more of those research-oriented ones. As a side point, I'd also suggest people take a little bit of look into the current work that's going on in the state of Hawaii and their Public Utilities Commission on microgrid dockets and then performance-based regulation, because there's technology vendors, utilities, but then we're all playing within a market which has some other influences, and some of those markets have regulators, whether they publicly elected or privately, and so that's important to understand kind of the rules of the game, what's forcing the market influences. From the university's perspective as a researcher, there's various types of resources, the DOE, NSF, various DoD. One that I would specifically point you to from a test lab perspective is something called DURUP, and it's Defense University Research Instrumentation Program. And that funds up to $1.5 million to be spent in a 1-year period, and it's specifically focused on instrumentation. And so, my work here at my test bed is expanded out from a variety of different sources that I've kind of amorphously grown over the last 2 to 3 years. That's a good opportunity to do a one-stop shop and build out, a modest to moderate size lab to get yourself going at, as Clark was saying, and I would agree with, that kilowatt scale where you're still able to do a lot of the primary, secondary, tertiary control and integration work without needing to buy, a 2-megawatt battery. It doesn't make sense from a practically standpoint from a research. So if you have that, 1.1, 1.5, or maybe $3 million in a research lab, or even less, that's fine. And then connect with your facilities to say, how can I utilize this lab in non-research conditions to offset some of your bills or offset some of your carbon? Then you can have multiple ways that asset or those assets can benefit the university. And as a consequence, you'll have more people from facilities interested, potentially utility, and that itself will increase additional dollars, which is, as we see sometimes from the Department of Energy, requires cost share. And so I'll stop there. That was just a couple of ideas.
That was great. Thank you so very much. Actually, what you've been talking about also relates to a sort of a follow-up question. And that's talking about some of the bigger challenges with respect to bringing together research, education curriculum, finance, and facilities management. And how might a university or college be more successful in terms of tying those different aspects of university operations together? So research, education, finance, and facilities.
Donuts. My simple answer is donuts. There's a great donut shop down the road that makes these custom crazy Hertz donuts is what it's called. And basically what that means is establishing a relationship that is enjoyable and friendly, and then work from there. Because traditionally, from university admin to facilities to research to the students, those are 3 very separate verticals that report all to the president, and they generally don't interact with one another. And so you need to get out of your office, do more than send an email or a phone call, but establish a relationship. And the way I did it the first time was donuts. And now we have a really good bi-directional relationship. They brought over coffee a couple times and have been absolutely invaluable, the ASU facilities crew, in understanding the processes and programs to help with interconnection agreements, getting land, building it out, but then also working with our heads of finances, which manage ASU facilities, and how the research we do can benefit ASU's bottom line through peak shaving and demand response. But it all started with saying, realizing that we're in very different architectures or places of the ASU or university architecture, and then bridging that, and then listening, and then actually talking about strategic ideas.
Okay, great. Thank you very much.
Hey, Eric, can I add? Can I
sure,
just
of course.
That? Sure. It's just,
sure, Clark.
I don't think I can top donuts. There's no way, but I'll just say that some of the things one of the things that's always been interesting to me is, as I'm talking to various higher eds, I use the term shared vision. Whenever I'm invited to have an initial meeting, what is a shared vision that is going throughout the institution from the president, sometimes even the board, certainly the staff? And if there's a shared vision of distributed generation and other elements that are part of the student experience, because it all comes back to what is our brand and what is the student experience that the institution and the individual people want to impart on those kids. And if that all matches up, then all of a sudden you start whiteboarding about, okay, how can we take what's going on in the education side, what's going on in the research side, and tie that to what we're going to demonstrate of our own campus in order to save money, to reduce our carbon footprint, et cetera, et cetera. And once that happens, you start seeing that integration of people. And I guess I would say, combined with the donuts, boy, that would taste awful good.
Yeah, yeah. So I think what you're saying is also that it's not always about dollar and cents. It's not purely an economic decision that brings these different groups together to work.
Exactly. A lot of times you can make the dollars and cents work. There has to be some economic benefit. Let's not be too idealistic, but you find a way to make the dollars and cents work if you really want it. We do that with everything we do in life, I think.
Yeah. Do alumni ever play a role in these kinds of considerations? So like an alumnus who's, sometimes they give money for a LEED certified building, but it's sort of harder to get a alumnus to give money for a pipe that's under the ground. Do either of the three of you have thoughts about how donations from outside sources sometimes have an influence on decision making?
That's a very fair, very reasonable request and remark, and I'll provide some details. It is all foundation or individual dependent, and also to the university and what they're seeking. And donations or endowments may also, just as a side note to be aware of, might go to CapEx, but not operating costs. And once you build it, there's going to be additional costs to potentially have with the building. And so being aware of that when you're having those, conversations is always good. At Arizona State, we've been fortunate to be working with the Wrigley Foundation and then also the Walton Foundation on their sustainability goals and metrics, and locally and globally. Both of those groups have tended to have a global focus, yet at the same time, some of the endowments and foundations that they've set up to support Arizona State's operations have included building retrofits, additional structures, and then also hiring lines for admin support, technical support, and students.
Okay, I have gone through the questions that were shared with me. We have about 7 or 8 minutes left. Do any of the three speakers have a question that they want to ask of each other?
Eric, I was going to answer a question. I saw a question, I think, that somebody asked what simulation, if we used PSSDE, Power System Simulator, for distributed energy. The answer is yes for Siemens. Now, that is the tool we use for simulation that I described. I think Nate can speak for what they use, but that's what we use.
Yeah, very good question. And given some of the strength of the ASU Siemens relationship, there's a few licenses and utilizations that we have from the Siemens portfolio software that we use. And so we use PSSE, of course, but then also from NDE. From most of our microgrid build out, we use an online program, which is NDE, as I was indicating previously. And then from our control standpoint, a good amount of our control algorithms are built from our techniques for asset scheduling and forecasting. And then we might need a third-party nonlinear equation solver that we get. But that's probably more of a coffee and donut conversation if people want to talk about that science fun side of it. One other thing I saw people asked is how will electrification I think it was how does the transmission infrastructure affect the distribution? Maybe I saw it as the question for there. For our standpoint at the university, we are interested and engaged with the quality and voltage stability in our local area, but at that transmission scale, the substation or the transformer is going to handle that variance or potentially change the low tap settings. And so as long as wherever, whatever voltage level you're at, you're handling that appropriately, the potential issues with up the scale or down the scale, unless there's larger cascading failures, shouldn't be too big of an issue for you.
Okay, great. Thanks for providing a little more technical background.
Eric,
yes?
There's another question on there I'd love to answer here. It's what universities have built out renewables in tangent neighborhood with residents as clients? I won't say that that's been done yet, but the first microgrid cluster actually is being done by Commonwealth Edison. So you can Google this. It's the Bronzeville project in Illinois, and it's the Illinois Institute of Technology that has had distributed generation and a microgrid in place for a couple of years now. And what the utility is doing is it's expanding that microgrid to outside the university footprint, again, to the surrounding neighborhood, as the question asks. So that's now going to be done. It's the first microgrid cluster for any utility out there. So that should spur on others to follow in suit. And I'll also say that what's being done out there is due to resiliency issues and due to all the storms and other things that you're seeing out there. There's a number of entities, including ourselves, that are looking at, I'll say, a larger microgrid or mini grids that combine university campuses with the local hospital, with the local community, because there needs to be a place to go. When those disasters hit, where are people going to go? They need to go somewhere for power, for water, and for food. And by having that distributed generation in place and a microgrid to be able to work with the utility grid, you've now given yourself that resiliency as a city or a local community. So that's the concepts out there, and the first microgrid cluster is actually in development.
Wonderful news. Thanks so much. We're down at the end of our time here, so I'd like to thank the three speakers very much for participating in today's program and sharing some of their unique knowledge and experience. And thanks also to the attendees who were able to hear what we had to say. I'd like to remind everyone that your friends and colleagues will be able to listen to this webinar online. It should be posted on the Second Nature website by the end of next week. And I'd also remind you that Second Nature, Siemens, and Arizona State will be strongly represented at the upcoming Higher Education Climate Leadership Summit. That's going to be held in Arizona, Tempe, Phoenix, on February 10 to 12. And actually, the deadline for early bird registration is tomorrow. So go to the website, which is listed here on your screen, along with the website for where to go to listen to the webinars. So thanks so much to all of you for joining us today. We will have new webinars coming up in the new year and look forward to hearing from you then. Thanks so much. Bye-bye.